surface off the board and it'll be good. Okay. So, here we go. Now we're going to talk about the planets. So the planets in order would be what?
Mercury, Venus, Earth,
Mars,
Saturn, Jupiter.
Saturn,
Sun, Mercury,
Venus,
Earth, Mars.
Pluto.
All the stars, Jupiter, Saturn.
Why does everybody forget a bit?
It's a song.
It's Mercury, Jupiter,
Then Sun.
So this is what I think of. Okay, we start with the sun, and then I just like do Mercury, Venus, Earth, Mars for memory. I mean, everyone knows that this is the third rock from the sun, Mercury, Venus, Earth, Mars. Then you have the asteroid belt, right? Maybe that used to be a planet and got collided with something else, you don't know. Then I just think like Jason, so Jupiter, Saturn, Uranus, and Neptune. And
You can sing them today, ABCs too.
can you? Oh.
Wait, what? That's what you were just saying?
You want to memorize that. I think it's literally a test question. Like,
Then you should memorize the song for sure.
so whatever it takes to memorize that, learn a song, just memorize it. When you think about which planet gets the most incoming solar radiation, insolation, which planet is that?
Pardon?
It's Neptune.
No, isn't it Venus?
It's Mercury.
Venus is the hottest because it has
Mercury
carbon dioxide.
Mercury gets the most. So who gets the most insolation?
Venus.
Mercury.
Mercury gets the most insolation. Venus is the hottest because it's more effective at scrapping the
Carbon dioxide.
energy. Yeah, its atmosphere is mostly carbon dioxide, so it
What are
traps
Uranus
the-
and Mercury? Earth, sorry, Mars. What is that? I know it's a gas planet.
Okay, so all
baby toys.
if you look at the planets here, the inner planets are all terrestrial. The inner planets are terrestrial. That means you guys know, like the word terra, that root word terrestrial. The word terra means land, like dry land. These are planets made of solid stuff. These guys are the outer planets, and they are gas giants. So they're made of light elements like hydrogen and helium, and they are. There's not really a place to stand until you get right to the center. But their mass consists of a huge amount of gas.
You seen the outer planets?
The outer planets.
They're the gas planets.
Gas
mostly.
planets.
And the inner planets are more solid.
So they're our planets are solid. The outer planets are mostly gaseous. But I mean, they still have a large mass because they're really, really big. Even though their mass is a lot made of gas, and it's clearly gases are lighter per volume than solids. So Mercury gets the most insolation, even though Venus is the hottest planet, because it has an atmosphere and Mercury doesn't. So the atmosphere can trap the heat.
Mercury has no atmosphere?
Not much. So not a great place to live. But some of the planets have like atmospheres of like sulfuric acid and stuff. So they're not.
It's phenomenal that our planet is the only one that's perfect for living.
It is.
I find it funny when people go and talk about how, like, life on other planets. I'm like, well, you have to take in consideration all these different elements. You have to be the right distance away from the star or
and the right
sun,
kind of star.
Yeah.
Because our star is
Red
smaller
giant?
than
What if we had a red
most.
giant?
It's cooler than most. Stabler than most.
Yes.
There's this YouTube video.
Better than most.
There's like a scale of like size like things and
Yeah.
and then it started with like planets and then it just got done getting bigger and it's like
Everyone should go watch that YouTube video.
that is like really cool.
Pluto's a planet. I think it's a planet. It's just frozen.
No, it's not
I'm
even a
perfectly fine with calling it a dwarf planet.
I think it's a planet.
It's
It's
not
just
round
so far
enough.
away from the sun.
Yeah, but it's not round enough. Like it doesn't have the size to make its gravity cause it to be round enough. So I don't think.
Yeah.
But I don't know. I mean, I'm not that fussy about that. Perturbations are little variances in the orbit of planets. So the sun's gravity provides centripetal force, and the planet's velocity is perpendicular to that, causing them to orbit. But remember that gravitational attraction happens between any two things with mass, whether they're two little marbles here on Earth, or like Earth and the Sun, or Earth and Mars, or Earth and Uranus, right? So all of the planets affect all of the other planets. Every comet and asteroid and little thing in our solar system affects our orbit, right? Even me doing this affects our orbit, but so tiny of an amount that it doesn't matter, right? Because somebody else could do that somewhere else, and it just doesn't matter. But large masses, like other planets, can affect our orbits a little
If you were
bit.
to drop like the heaviest mass on the Earth would come up to it.
Even the smallest mass makes the Earth do something.
I know, but like I mean, like
Everyone
you'd actually
on
be able to
Earth
see it.
Jumped
Probably
at
not.
the same time.
No, but then the Earth would be like that'd be really cool, wouldn't it?
Well, but I mean, we know as the moon orbits the Earth, the moon is one of our satellites, right? A natural satellite, not a man-made satellite. But we know that it does cause like a little bit of bulging as one side of the Earth is attracted toward the moon, right? The water especially bulges a bit.
That's why you have the tides.
So, I mean, we see this, and every mass attracts every other mass because of gravity. Oh no, did I hit a button? Let's watch you guys. You're more interesting. Asteroids. So focus. Asteroids have collisions sometimes, right? There are tons of asteroids, especially in asteroid belt. Sometimes something will strike them. Maybe another asteroid will strike. Maybe a comet will strike. Who knows? But when there's a collision, sometimes the orbit of an asteroid can be disturbed. And it can just be knocked out of its orbit, leave the asteroid belt entirely sometimes. And sometimes it could start to be attracted in toward another planet by the gravity of that planet. If an asteroid is pulled in by Earth's gravity, right? If an asteroid's path intersects Earth's orbit, it is a meteoroid. If it actually burns up in Earth's atmosphere, in the mesosphere, remember?